ladies and gentlemen, here's the situation we have in this last word problem. We're trying to find the maximum area. A rancher needs to enclose two adjacent rectangular corrals. One's for cattle and sheep. A river forms one side of the corrals, which means we don't need fencing along the river. And 330 yards of fencing is available. What is the largest total area we can enclose? Well, let's draw a little picture here. I've got a river, and I've got two adjacent rectangular corrals, meaning they don't have to be the same size, but they share a common fence. Okay, they're touching, and they're both rectangular. I have 330 yards of fencing to work with. Now, again, in class we talked about how stupid this is because I think the sheep would probably drown and the cattle would swim away. But so what we did is we put this, remember what we did is we put this way up on a cliff, and we assumed that the animals weren't suicidal, so they weren't going to dive to their death. Okay? Now, I have 330 yards of fence. I'll call this dimension X yards, likewise here, and likewise here. So 1x, 2x, 3x has already been used up. I have 330 yards of fence total. So what's left to put along here would be 330 minus 3x. Okay? X was 3x, so what was left over to roll out here was 330 minus 3x. Now, we need to create the area function, so we'll call it a of x because the area depends on x. And you know how to find area. The area of the enclosed pens would be length times width. So x times 330 minus 3x. So a of x is equal to 330x minus 3x squared. And if I put that in the appropriate order, a of x is equal to the opposite of 3x squared plus 330x. Okay? That is my area function. Now, this area function, if I graphed it, is a parabola opening down. So, of course, it's going to have a maximum if a parabola is opening down and the maximum occurs at the vertex. So what I need to do here is locate the vertex. And in order to do that, I use the vertex formula. Remember, the vertex formula tells me x is the opposite of b over 2a. So we would have the opposite of b is 330, it's what's in front of the x, divided by 2 times a. A is the leading coefficient, which is negative 3. Negative, negative, of course, positive. 330 divided by 6 would be 55. So x is 55. But that's not what we were looking for. We were looking for the maximum area. So what we have to do with that number 55 is plug it into this function. Okay? So what we have to do is put 55 in here. So I'm going to go to my calculator and let me type in the opposite of 3, and then in parens I have 55 caret 2, which squares it, right? That's the first part of it, minus 3 times the input squared, plus, so I'm going to hit a plus, 330, and then in parens 55 again. Okay? I plugged it into my area function and I hit enter, and I get the answer 9075. So, to answer my question, okay, remember the output represents area, the input represents x. This is x and this is a of x. The question said, what is the largest total area that can be enclosed? The y value of the vertex is 9,075. So the answer would be 9,075, and let's use the appropriate units. Since it's area, we would be talking about square yards. Now, what might also be asked on a test would be, what would the dimensions of the rectangle be? Well, in order to find that out, x was the dimension, so this x would be 55 yards, so 55 yards wide, and then 330 minus 3 times 55, let's see what that would be. I think it's 165, but let's see, 330 minus 3 times 55, and hit enter, and we get 165. So, the question that was asked, we've already answered. 9,075 square yards is the total enclosed area as a maximum. And if they were to ask you what dimensions got that, 55 yards this way and 165 yards this way. And we're done.